Hello friends, here we are going to solve another question from Indian Regional Mathematics Olympiad or RMO of 1992. And here is the question. Find all the integers n for which this expression n square plus 19n plus 92 is a perfect square. This expression. So how can we proceed? We have to check if this expression is equal to some perfect square or not. First of all, we don't even know whether such a solution really exists or not. Let us just assume that there is a solution, and this expression n square plus 19n plus 92 is indeed equal to some perfect square t square, where t is a positive integer. Even if t is a negative integer, doesn't matter because we are dealing with the squared version of it. Now here you see the left hand side is not easily factorizable. It would have been really nice if we could have easily factored out the left hand side, but which is not. Then what can we do? Well, we can subtract 2 from each of the sides to make the left hand side easily factorizable. So let us do that. So we have n square plus 19n plus 90 is equal to t square minus 2. Now you see the left hand side becomes easily factorizable. So let us do that. We have n plus 9 into n plus 10 is equal to t square minus 2. So here you see the left hand side is basically now is a product of two consecutive integers. Let us denote n plus 9 as k. So this thing becomes k into k plus 1 is equal to t square minus 2. Okay. Now one thing we immediately observe here is that k cannot be 0 or k cannot be equal to minus 1, because if you put k equal to 0 or k equal to minus 1, this left hand side will immediately collapse to 0, but the right hand side cannot be 0. That means these two values 0 and minus 1 are not allowed for k. So that means either k is greater than 0 or k is less than minus 1. So we have two cases in our hand. Let us evaluate the cases. The first case is when k is greater than 0. Okay. So in this case, let us first simplify the equation a little, and we get from here directly we get t square minus k square is equal to k plus 2. Okay. Now here you notice the right hand side is always positive. Therefore the left hand side must also be positive always. That means t cannot be equal to k. T has to be greater than k. That means t can be written as k plus some delta. And this entire thing becomes k plus delta square minus k square equal to k plus 2. Now what is this delta? This delta is basically the difference between k and t. And since t cannot be equal to k, t always has to be greater than k. This delta is therefore always greater than or equal to 1. That condition we have to keep in our mind. Okay. Now let us simplify this again. So what do we get here? We get 2 minus delta square is equal to 2k delta minus k. Now observe this relationship carefully. the minimum possible value of delta is 1. If we put delta equal to 1 here and solve it for k, we get k equal to 1. So for delta equal to 1, we get k equal to 1. And this k equal to 1 is one solution. K equal to 1 is definitely one solution. Now delta was always greater than or equal to 1. For the minimum value of delta, which is 1, we got a solution. What if delta is greater than 1? Well, here we see that if delta grows beyond 1, if delta is assigned to some value which is greater than 1, then immediately the left hand side will become negative. But the right hand side will still remain positive. So which is a contradictory situation. That means delta cannot be greater than 1. So the only possible value for delta here is 1, and for that we got a solution, that is k equal to 1. So k equal to 1 is definitely one of the solutions. So we note it down here. Okay, now let us come back to the other case. We have already evaluated this case where k is greater than 0, and remember k cannot be 0, k cannot be minus 1. So the only other case remaining is the case where k is less than minus 1. Now if k is less than minus 1, then let us assume k equal to some minus m. What is this m? This m is some positive integer greater than 1. Okay. Now let us put k equal to minus m in the original equation, and we get minus m into minus m plus 1 is equal to t square minus 2. Basically, we have just put k equal to minus m here in the original equation, and we got minus m into minus m plus 1 equal to t square minus 2. But notice the left hand side. It is basically a product of two consecutive negative integers, which is same as multiplying two positive consecutive integers. If we just flip the signs of these numbers, the ultimate result will not change. So let us flip the signs, and this thing will become, the left hand side will become m into m minus 1 equal to t square minus 2. But what is this? M into m minus 1. This is basically a product of two consecutive positive integers, which is equal to t square minus 2. And this equation is same as the original equation. The original equation was also the same. It was basically an equation where we had a product of two consecutive positive integers, which was equal to some perfect square minus 2. And this thing is also the same. And we already know the solution for this. We have already solved it. And we know that if we have such an equation, then the solution for that is the value of the smaller integer will be 1. In this case, k was equal to 1. So the same solution will also apply here, and the value of the smaller integer will be 1. That means m is equal to 2. Now since m is equal to 2, k was minus m, therefore k is equal to minus 2. This is another solution. So here we have two solutions, k equal to 1 and k equal to minus 2. Now let us just verify the solutions. Let us draw a table here for k, n and the given expression n square plus 19n plus 92. So we had only two solutions, k equal to 1 and k equal to minus 2. And we know the relationship between k and n. K was nothing but n plus 9. So for k equal to 1, we get n equal to minus 8. And for k equal to minus 2, we get n equal to minus 11. Now if you plug in the value of n equal to minus 8 in the given expression, and if you just calculate a bit, you get, it becomes 4. If you plug in the value of n as minus 11 in the given expression, you get the value of 4 again. And what is 4? 4 is a perfect square. That means for n equal to minus 8 and for n equal to minus 11, the given expression in the question indeed produces a perfect square. And these are the only two solutions. So what was the question? The question asked us to find all the integers n, and we have found it. There are two possible solutions, minus 8 and minus 11. So friends, these are the two possible solutions. I hope you have enjoyed the video, and please feel free to like, comment, share and subscribe to my channel. Thank you.